Hi everyone, welcome to SriSai online training. Today in core Python programming, we are going to discuss the following topics: data types in Python fundamentals, and then we'll discuss standard data types or built-in data types in Python. Right. So first of all, we'll have a small revision what we discussed in the previous session: Python fundamentals, keywords in Python, lines and indentations, quotations and comments, variables and assignments. So coming to the Python fundamentals. So fundamentals means basics of writing a Python program. So in Python, we have 8 fundamentals. First one, identifiers. Second one, reserved words or keywords. Third one, data types, what we are going to discuss today. Fourth, conversions. Fifth, string slicing. Sixth, typecasting. Seventh, escape sequence characters. And eighth, constants. So in the last session we discussed about keywords. So keywords are reserved words or predefined words with special meaning and special usage in a program. So in Python we have total 33 plus keywords, 30 plus keywords. So how to verify the keywords? It is very simple. We have to go to the command prompt and then Python interactive mode. So here we have to say import keyword. Okay, so keyword is a predefined module. Module means it is nothing but a Python file. Now in this file we have one variable. So that variable is, okay, so keyword dot kw list. So when you say keyword dot kw list, it will list all the keywords which are supported by Python. So these are the different keywords which are supported by Python. Right. So we'll say exit. Again, we'll come back to the Windows command prompt. Right. And then we have also discussed lines and indentations. So whenever we want to write a block of code, in that block of code for multiple statements, we have to give equal number of spaces. So no need to use curly braces. Okay. Just we have to give equal number of spaces from the left side. That will become block of code. We have also discussed quotations and comments. So basically quotations means we have single quotations, we have double quotations, we have triple single quotations and triple double quotations. So we can use string to represent any type of quotations, and if you want to represent multi-line string, we have to go for triple single quotation, triple double quotation, and we can also use triple single quotation to represent comments. Right, and then we have also seen how to work with variables. So variables are used to store a value in a program. A is equals to 10, B is equals to 20, and we have also seen variables with multiple assignments. A is equals to, B is equals to, C is equals to 10, or something like A comma B comma C is equals to 10 comma 20 comma 30. So A will be 10, B will be 20, C is equals to 30. Right, so this is what is all about we discussed in the previous session. So coming to data types in Python. So data means information, any information which is used by the end user of a computer. Type. So type means which information. So what is the definition of data type? So the definition goes like this: which type of information is accepted, stored, processed and displayed in a program, is known as data type. So accepted, stored, processed, and displayed as output in Python program is known as data type. So basically in Python, we don't require data types to store a value in a variable. For example, roll number 1001, name Sai, double quotations, height 6.0. So here, based on the value, it will take the data type automatically. So roll number. So roll number 1001, automatically it becomes integer data type. Name Sai, automatically it becomes string data type. And then finally height, real number, automatically it becomes floating data type. So this feature is called as dynamically typed language. So based on the value, data type is taken. Okay, so based on value in variable, data type is taken. So this feature is called as dynamically typed programming language. Right, so this is what is data types. So data means information, type means which information. Now let us discuss what are the different data types or standard data types which are supported by Python. So basically, standard data types means predefined data types, inbuilt data types, system defined data types, basic data types, primary data types, or primitive data types. So in Python, we have 5 standard data types. Okay, so we have 5 standard data types. First one, integers, int, real numbers, float, imaginary numbers, complex, Boolean values, bool, string values, string. So these are the 5 standard data types: int, float, complex, bool, str. Now we also have derived data types. So derived data types means these data types are derived from standard data types. Okay, they are derived from standard data types. So they are bytes, bytes array, range. Next, list, tuple, set, frozen set, dictionary. So here, list, tuple, set, frozen set, dictionary. For this, we have separate chapters only. Okay, for this we have separate chapters. None. So none means nothing or no value. So these comes under, right, derived data types. So derived data types are derived from standard data types. Right, so before understanding data types, standard data types, we will discuss how variable memory allocation is done in Python. So case 1 goes like this. For example, if I take a is equals to 10, and after that I will take a is equals to 20. So this is case 1. So a is equals to 10. So first a points to 10. After that a points to 20. Right. So let us try to understand this. Okay, how this is done in Python programming. So internally what happens means in memory, okay, a. So a will be pointing to 10. So when we say a is equals to 20, now in this case a will be pointing to 20. So now the reference will a will be pointing to 20. Okay, so this is what happens. So every variable in Python is an object. Okay, I'll write here every variable in Python is an object, because Python is a object oriented programming language. So initially first A will be pointing to 10. After that, when you say A is equals to 20, in that case, okay, A will be pointing to 20. Okay, so 10 is a memory location with a value and 20 is a memory location with a value. A is nothing but a object. Now case 2 goes like this. Okay, right. In case 2, let us say that A is equals to 10. So first A will be pointing to 10 in the memory. Okay, next we'll say B is equals to 10. So B also points to same memory. You will not get a separate memory, you will have the same memory. So now A, B both are pointing to 10 only. Now after that we'll say B is equals to 20. So when you say B is equals to 20, so now B will be pointing to another variable memory location which is 20. Okay, so now B will not be pointing to 10. B will be pointing to 20. But still A will be pointing to 10 only. So this is how in Python every variable is an object, and this object will be pointing to a memory location, and that memory location contains a value. So memory location means it will pointing to a address. Okay, so I'll write it here. Every variable which is an object refers or points to memory location. So memory location means address. Okay, so memory location contains a value. So 10 is a memory location with a value 10. So 20 is a memory location with a value 20. So this is how objects will be pointing to memory location which contains a value. So this is how memory allocation is done in Python. So coming to some technical points here. In Python, we have some built-in functions. For example, type. So using type, we can get the type of a variable. For example, we can say type of A. So type of A means it will return integer. Type of B, float. ID. So ID means it will give address of that particular memory location containing a value. So address is nothing but a unique identification of memory with a value. Okay, so address means unique identification of memory with value which contains a value. So how to use ID? Same like type. ID of A, you will get the address where A is pointing to in the memory. Similarly, we use print function to print data or a value. For example, we can say print of A. Next, ID of A and type of A. So these are some inbuilt utility functions in Python. And in Python, everything is an object, including variables. Right, guys? So this is how memory allocation is done in Python programming. So now coming to the concept of data types. So we'll discuss standard data types one by one with programs. First one, int data type. So int data type means it represents integer values. So integer values means negative numbers, positive numbers, as well as 0. Okay, negative, positive, 0. Now for example, let us take here a is equals to 10. We can get type of a. We can also get ID of a. ID means what is the memory location address of a where it is pointing to. So let us try to demonstrate this with a small program, datatype example1.py. So program to work with int data type. Okay, right. So first we'll put a comment, multi-line comment for remaining cases. So multi-line comment, we put it with 3. So 3 triple single quotes. So first I'm taking a is equals to 10, print a 10, print type of a, print ID of a. Okay, so save this. Now come to the command prompt, save this in your working directory py datatype example1.a. So a 10. Next, after that we have printed type of a. So type of a is class int. So int is a class in Python and 10 is an object of integer class, and this is a unique address of 10 where a is pointing to in memory. 24107516835152. Okay, next we'll take another value here. A is equals to -10. Now this is another value. Now a will be pointing to another memory location. Print a, type of a, ID of a. Right, so we'll execute till here, save this, recompile, run. So now a value is -10. So what is the data type of a? Type of a, it belongs to class int. Okay, and -10 is the object. So everything is an object in Python. Now if you see here, we got another memory location 888, previously 752. Okay, right. So now we will take a is equals to 0. Now a will be pointing to another memory location whose value is 0. So print a 0, type of a, it belongs to class int, and then ID of a, unique address where 0 is available. So save this, run. So now value is 0, data type class int. So this is the another address 0064. Now what I will do, once again I will say a is equals to 10 in the last. Print a, type of a, ID of a. Right. So run this. Now if you see here, now a is again pointing to 10. Initially 10. Address is this. So again it is pointing to the same address. So what is happening when I say again a is equals to 10? So here again a points, okay, to previous address. Okay, so previous address value is 10. So this is how it will reuse the values which are available in the memory. Okay, right. So I'll write here, point goes like this. In Python, values, okay, at particular memory location are reused by different variables. Okay, they are reused by different variables. Right, guys? So this is how we are supposed to work with integer data type. Right, now coming to some technical points here. So basically, we don't have long data type in Python. Previously it was there in Python 2, but from Python 3 we don't have long data type. In integer data type only we can store big values also. So long data type is not supported from Python 3. Okay, guys? And coming to integers, in integers Python supports different number systems. Okay, so these are mathematics. In mathematics we have number systems: decimal number system 0 to 9, binary number systems 0, 1, octal 0 to 7, hexadecimal 0 to 9, 10, 11, 12, 13, 14, 15, A, B, C, D, E, F. This is how 4 number systems, okay, are supported by integers, int data type in Python. Now if you take decimal, so decimal means it is a number to the base 10. In decimal number system we use 0 to 9, and this is the default number system. So when we say 10, 20, minus 10, it comes under decimal number system. Example, a is equals to 10, a is equals to minus 10, a is equals to 0. Similarly, binary number systems. In binary number systems, we have base 2. So here we use only 2 digits, 0 or 1. And here binary numbers are prefixed with 0b or 0 small b. Example, a is equals to 0b. So 0b means it is a binary number 1010. So 1010 means it is equal to 10. It is equals to 10 in decimal number system. Okay, 1010. Similarly, octal. So octal means to the base 8. So here we use only 0 to 7 digits, and it is prefixed with 0O, capital O or small o. So it is equals to 0O 1 2 3. Example. So 1 2 3. So 1 2 3 means it is 8 power 0 plus 8 power 2 plus 8 power 3. So it will take the value like that. So this value is equals to like this one. Okay, so 123. So 2 power 0, 2 power 1, 2 power 2, it will take that in binary. So here we have to take 3 into 8 power 0, 2 into 8 power 1, and 1 into 8 power 2. So 1 into 8 power 2. Okay, so 8 8s are 64, plus next 2 into 8 power 1, 8, plus 3 into 8 power 0, 1. So the answer will be 64 plus 16 plus 3. Okay, so 64 plus 16, 80, 80 plus 3, answer is 83 in decimal. Okay, so similarly hexadecimal number. So hexadecimal number means we'll have base 16, and here the supported digits are 0 to 9, and 10 to 15 we can take capital A to capital F or small a to small f. And these numbers are prefixed with 0x, capital X or small x. Example, a is equals to 0x 1ae. So how to get this value? So it is 1 into, okay, so 1 into 16 power 2. Okay, so 16 16s are 256 plus A. So A means 10. So 10 into 16 power 1, which is 16, plus E. So E means here A, B, C, D, E. So E means 14. Okay, so 14 into 16 power 0, which is 1. So let us try to calculate this value. 256 plus 160 plus 14. Okay, so 256 plus 14, which is 260, 270. So 270 plus 260. Okay, so 270 plus 260 plus 160, which is equals to 530. Okay, so 430. Right, so this is how we are supposed to get decimal to binary, binary to octal, octal to hexadecimal. Okay guys, so these binary, octal, decimal, hexadecimal values are converted to decimal automatically by Python Virtual Manager. So these are different number systems which are supported by int data type in Python. So now let us go to number system conversions. So how to convert one number system value to another number system value, right? So how to convert one number system value to another number system value. So basically what we are going to do is we are going to convert decimal to binary, decimal to octal, decimal to different number systems. Okay, so we'll try to do that. So for this we have 3 bin. It converts any number system to binary value. Oct. So this function converts any number system to octal value. Third one, hex. It converts any number system to hexadecimal number. Okay, right, so let us try to understand this. Okay, right, so program to convert values in integer number system. Okay, right, so converting values from integer number system. Okay, right, so how to take this? So first we'll start with binary. So we'll put a multi-line comment. So save this program in our working directory. So binary of 10. So we should get 1010. Okay, right, so binary of 10 means 1010. Similarly, okay, we will take directly something like this okay, so any to binary or octal or hexadecimal. So we'll take all 3 cases at a time. Okay, so if you see the previous example here, in the previous example, so we have taken binary of 10, which is 100, 1010, octal of 83, 123, and hexadecimal of 430. We should get 1AE. So let us try this one only. Okay, so 10, 83, 430. So octal of 83. Okay, right, fine. And then, okay, first we'll see binary of 10. So save this. Okay, come to the command prompt. So py numsys convert. Okay, so 0b 1010. So 10 is converted to binary. So similarly, next we will convert 83 to octal. So save this, run. So we got 00123. Okay, so 123 is converted to, 123, which is a representation of 83 in octal. Next, hexadecimal. So print hexadecimal of 430. So save this, run. So 1AE, which is hexadecimal representation of 430. So this is how we are supposed to convert integer to binary, integer to octal, integer to hexadecimal. So similarly, we can also convert other numbers into different numbers. For example, I'll take here a is equals to 0, b, 1010. So now I'll say print a. Next, second case, a is equals to 0 o octal. Okay, so 0 o octal 123. Okay, print a. We should get the answer as 83. Third one, a is equals to 0 x 1 a e. Now here we should get the answer as 430. So save this, run it. So 10, 83, 430. So this is how we are supposed to work with number system conversion functions, binary functions, octal functions, and hexadecimal functions and its corresponding program. So now coming to the float data type. So float data type are used to represent floating point values or decimal values. So decimal values means, okay, with decimal point. Okay, decimal values with decimal point, or simply you can also say it as values with decimal point. And in mathematics, these are called as real values, mathematics. So example goes like this: a is equals to 123.456. So this is a standard way of representing float value. Okay, we can also represent in scientific notation. For example, a is equals to 1.5 E3. So E3 indicates extended to the power of 10. Extended to the power of 10. So which means the value goes like this one here. Okay, 1.5 into 10 power 3. Okay, so that is what is extended to the power of 10. So 10 power 3 means it is 1000. So 1.5 into 1000, which is equals to 1500. Okay, so standard notation and scientific notation of floating values with decimal points or real values. So let us try to demonstrate this with a small program, Datatype 2. Okay, so program to work with float data types. So first we'll take a is equals to 12.345, print a, type of a, id of a. So we'll execute till here, save the program in your working directory, come to the command prompt and run datatype example 2. So value of a is 12.345. Its data type is class float. Okay, and this is the unique address where we have 12.345 in the memory. Okay, so now we will take extended to the power. So a is equals to 1.5 extended to the power of 3. So print a, type of a, id of a. Save and run. So now answer is 1500.0 into 10 power 3 into 1000. So it belongs to the data type class float, and this is the unique address where we have 1500.0 in the memory. Now let us take a is equals to 1.5 extended to the power of minus 3. So minus 3 means into 10 power minus 3 means 1 by 1000. Okay, so now let us try to get values. So divided by 1000, which is 0.0015. Right, so this is how we are supposed to work with float data type. It supports standard notation and scientific notation. So in scientific notation, we'll have extended to the power of 10. Right. So now coming to complex data types. So basically, complex data types. So they are called as complex numbers with I. I means imaginary number. So we use this in scientific applications. So scientific applications or scientific calculations, complex data types. Example, A plus BJ. Okay, so A is real part, BJ is imaginary part, and J value is square root of minus 1. And here A, B can be integers or floating values. So it's very simple here. A is equals to 3 plus 5j. A is equals to 10 plus 5.5j, or A is equals to 0.5 plus 0.1j. So let us try to demonstrate this with a small program. Data type example 3. Right. So let us take data type example 3. So program to work with complex data types. Okay. So we'll see all the three cases one by one. A plus BJ. So generally we don't use this. It is used in scientific applications mainly. Okay. So 3 plus 5j. So print A, type of A, ID of A. So save this. Okay. In your working directory. So come to the command prompt and run py data type example 3. Data type example 3.py. So 3 plus 5j, data type is class complex. This is a unique address in the memory. So we can also take 10 plus 5.5j, second case. Save this, run. So 10 plus 5.5j, complex unique address. Third case, A, B, both are real numbers. 0.5 plus 0.1j, and then print A, type of A, ID of A. So 0.5 plus 0.1j, complex. So now let us start with Boolean data type, which is called as bool data type. So Boolean data type, it is used to represent Boolean values. So here it will take only two values more. True, false. So in true, T is capital. In false, F is capital. So internally true means 1 and false means 0. So how to use this? It is very simple. A is equals to true, or we can also take it as false. We can print type of A, ID of A, as well as A. So let us try to demonstrate this with a small program. So data type example 4. So program to work with bool data types. Okay, right. So first I'm taking A is equal to true, type of A, A. Next B is equals to false, type of A, B. Right, so we'll execute till here. So save this in your working directory and then come to the command prompt. So in command prompt, run py datatype example 4. So first bool data type true, second time bool data type false. Now we can also use this for condition expressions. For example, a is equals to 5, okay, b is equals to 3, so c is equals to a less than b, so 5 less than 3 false. So print type of c and false, and then a greater than b, 5 greater than b, true, print true. So first time false, second time true. So save this. Right, so come to the command prompt and run it. So first 5 less than 3 false, 5 greater than 3 true. Okay, so this is how we are supposed to work with bool data type, true, false, only two values. So now let us discuss the fifth standard data type, str data type. So it represents string data type. So what is string? So string is a collection of characters represented in double quotes or single quotes. For example, S1 is equals to hello, double quotes. S2 is equals to welcome to Python, single quotes. Or you can also take it like this. Generally we take single word in single quotes, multiple words in a single line using double quotes generally. Now if you want to represent a string in multiple lines, then we have to go for multiple triple quotes and multiple single quotes. Okay, like triple double quotes and triple single quotes. Example, S1. So S1 is equals to hello world in 2 lines. S2 is equals to welcome to Python in 3 lines. So here we are using triple double quotes, triple single quotes. So let us try to demonstrate this with a small program, Datatype example 5. So program to work with str data types. So first I'm taking S1 is equals to hello, print type of S1, S1. Second, okay, we'll take this in single quotes because it is a single word. And second, we are taking S2 is equals to welcome to Python, print type of S2, S2. Right, so we'll put comment for the remaining 2 cases. Okay, right. So save this, hello, welcome to Python, S1, S2. So come to the command prompt, run datatype example 5. So first, hello, str datatype. Second, welcome to Python, str datatype. Now we'll take the string in multiple lines. So S1, hello world in 2 lines, print S1, S2, triple single quotes, okay, welcome to Python in 3 lines, print S2. Right, so save this, come to the command prompt, run. So first, hello world, 2 lines, welcome to Python, 3 lines. Now if you want here, we can also remove the tab space. So remove the 2 tab spaces here. Now they will come properly without any spaces. So hello world, 2 lines, welcome to Python, 3 lines. Okay, if you want, we can also remove this. Right, put semicolon at the last. So this is how we are supposed to work with str data type. Single quote, double quote, triple single quote, triple double quotes. Okay, all of you. So in Python, we have 5 fundamental data types: int, float, complex, bool, str. 5 fundamental data types, or these are also called as standard data types. Okay, right. So in Python, we don't have char data type. Okay, one of the important point in Python, we don't have char data type. So char is also represented in string only, single character. Okay, so single character as string only in Python. For example, char a. A is a single character, but we don't have char data type, so it will take it as string only here. Okay, so let us try to use this in the previous program, data type example 5. So in the last, we'll take it as ch is equals to a, print a, print ch, type of ch. So come to the command prompt, save it and run. So a is the value, data type is str only. So we don't have char data type in Python. Okay guys, all of you. And id function, it gives the unique address location of a value. Okay, and this address is given by Python virtual manager automatically. So now coming to the concept of deleting a reference variable. Now for deleting a particular reference from the memory, we use del statement. Okay, so it will delete that particular reference from the memory. For example, delete variable name, delete variable 1 comma variable 2 comma variable 3. So the example goes like this: delete a, delete a comma b comma c. So we can delete multiple variables at a time. So let us try to demonstrate this with a small program, delete reference variables.py. Right, so program to demo reference deletion. So reference means it will delete that address where value is present in the memory. Okay, right. So first we will take here 3 variables a, b, c. A is equals to 10, b is equals to 20, c is equals to 30. Print a, b, c. So save this program in our working directory, come to the command prompt and then run delete reference variable.py. So initially we have 10, 20, 30. So a is pointing to 10, b is pointing to 20, c is pointing to 30. Now we'll delete that reference. Okay, right. So for example, delete a. So a reference is deleted. So when you print a, you will get name error. Okay, we can print b, c, but not a. So if you see here, 10, 20, 30. So we got an error, name error. A is not defined because it is deleted from the memory. Right. Similarly, save it, put a comment for A. Now we'll get only B, C, 20, 30. Now delete both B and C. When we delete B and C, we cannot access B also, C also. We'll get a name error. So name error, name B is not defined. Okay, so we cannot access them. So this is how we are supposed to work with deleting a reference of a particular variable in our Python program. Is it okay guys, all of you till here? So last topic in this session, typecasting in Python. So typecasting means converting. So converting one data type value into another data type value is known as typecasting. Okay, so this typecasting is done with the help of Type-Coercion. Okay, So it is known as type coercion in Python. Okay, type coercion in Python, converting one data type value into another. So for this we all have built-in functions int. It converts other data types into integer. Float, it converts other data types into float. Complex, other data types into float. Bool, other data types into float. Str, other data types into float. So int function, float function, complex function, bool function, str function. So let us try to demonstrate this with a small program. Typecasting example.py. So last program for us. Okay, so program to demo typecasting with Python functions. Right, so we'll take all cases one by one. Easy to understand. So first we'll see int. Okay, right, so int, so print int of 123.456. We'll get only 123.456 is deleted. So save this program in your working directory, come to the command prompt and then run typecasting example. Only 123.456 is deleted. Next, int 3 plus 5j. So 3 plus 5j is complex number. It cannot be converted to int. You'll get an error. So cannot convert complex to int. Right. So similarly, print int of true. So true means 1. So it will convert true to 1. So the answer is 1. Similarly, int of false. Answer is 0. False means 0. Similarly, int of string 10. So string 10 will be converted into, okay, integer 10. Now for example, if you take something like int of high, will get a error. Okay, high cannot be converted to integer. Okay, fine. So high cannot be converted to integer, we'll get it as value error. Okay, right. So second case, float. So how to convert things into float? Okay, so first float of 10, so 10.0. Float of true 1.0. Float of false 0.0. Float of 10 10.0. So string 10 will be converted into 10.0. So float of 10.5 10.5. Right, so save this. Right, run. So 10.0, true 1.0, false 0.0, string 10.0, string 10.5 converted to float. Now here also again we cannot convert complex number to, okay, float, and ten. So it is a 10. So 10 in characters cannot be converted to float. Right. So we'll get a value error. Complex cannot convert to float, which is type error. Okay. Right, guys. So similarly, put a comment for this. So for this one also we'll get an error, which is value error. Okay. So type error and value error. So this cannot be converted. You'll get a type error. And this is a improper value. String ten cannot be converted to float. Right, now let us go for complex. Okay, right. So complex of 10 will get 10 plus 0j. Okay. Complex of 10.5. So 10.5 plus 0j. Complex of true 1 plus 0j. Complex of false 0 plus 0j, or simply 0j. Complex of string 10. So string can be converted to integer. So 10 plus 0j. So complex of 10.5. So 10.5 plus 0j. So save this and then run. So this is how complex conversions are done. Now complex of ten. So this cannot be converted to complex. So here again we'll get a value error. Okay guys, value error. Right, so let us put a comment for this. Now coming to Boolean. So in Boolean we have many cases. So we'll try to work with all these cases one by one. So first we'll see five cases. Okay. Right. So bool of 0, false. Bool of 1, true. Bool of 10. Any non-zero is true. Okay. I'll write here. Any non-zero is true. Boolean of 10.5, non-zero, true. So Boolean of 0.123. So here it will take in the last case 0. Right, so run it. So true, 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 true. So in the last case it is taking as 0.123, non-zero only. So non-zero means true. So 5 true cases. But after that we'll see few more 5 cases. Right, 4 cases. So 0.0, so 0.0 means it is 0 value, false. So 10 minus 2j, non-zero, true. So 0 plus 1.5j, true. So 0 plus 0.j, 0j, which is false, 0, 0. Right, so save this, run. So false, true, true, false. Right. So similarly, we can work with other cases also. For example, bool of true. So true means 1. 1 means true. Bool of false, false. Bool of empty. Empty means nothing. Empty string. So false. Bool of string 0, false. Bool of string 1, true. So save this. Compile it. So true, true, false, true, true. Okay. So here again it is checking true. So true, true, false. So only empty string it is checking as false. Okay. So only empty string is false. So it is not taking false for right. So any non-empty string, okay, is true. Right. So let us check for the remaining 4 cases. So bool of 0.0 as string, 1.0 as string. So true and then false directly. So any non-empty string, it is true. So we should get true, true, 1.0 as well as 0.0. So true and then false. So true means true only, false means false only. So last case. So print of string 10, string 10.5, 5 plus 3j, string 2, string false. So converting integer, floating, complex, boolean to string. So all these 5 values will be converted to string. So string 10, string 10.5, 5 plus 3j string, true string and false string. Right, so this is how we are supposed to work with type conversions using int, float, complex, bool, string functions. Right, so that is what is all about today's core Python programming session, data types in Python fundamentals, and we have discussed standard data types or built-in data types in Python. Thank you all of you for watching and listening this video. Have a nice day.